Hello dear students, welcome to my video on how to write and analyze an algorithm. When we try to solve any problem, there are several possible solutions available. Say for example, if you are having one problem P, there is a possibility that that particular problem can have many solutions like solution 1, solution 2, solution 3. Now how will we decide which solution to choose? So there are several factors that we have to keep in mind. The very first factor, that is how much time it is taking. If two solutions are there, we should prefer to choose the solution which takes less time. Same way in terms of space also. If it is taking less memory space, we should choose that solution. If you are transmitting data, so what is the network utilization? That may be also one of the criteria. If your application is consuming power, we should also focus on how much power it is consuming. And what is the CPU register utilization of our algorithm? Now to represent all these things and to explain all these things in detail, very simple algorithm I have written. You see, writing an algorithm is also an art, right? You have to write down here the name of the algorithm, and here in this case it is SWAG. And then you can mention here the number of arguments that you are passing. And the number of arguments are A and B. So here in this case, two arguments we are passing. And it's a very famous program code that you are knowing for exchanging the values, for swapping the value of two variables. Now there are various types of functions. When you see for an algorithm, sometimes your algorithm maybe it is constant algorithm, it is logarithmic algorithm, or it may be linear, or it may be quadratic, or it may be cubic, or in some case it may be even exponential as well. Now if you observe all these types of time function, the very first function, that is this order of 1, it is always going to take minimum amount of time. And if any algorithm is having time complexity in terms of order of 2 raised to n, it is going to take maximum amount of time. So they are in their increasing order of growth, right? So if you are having two solutions available, one is having complexity order of n square and another is having time complexity order of n cube, then we should choose order of n square solution, right? So if one problem solution is having n square complexity and another is having n cube complexity, so as we all know that n square is less than n cube, then definitely we should choose that particular. Now let us take one example of an algorithm and let us try to find out time complexity and space complexity. How we can find out time complexity and space complexity? So let us see one example related to it. So here in this case, this is an example again for swapping the value of two variables. So here our assumption is that per statement it is taking unit amount of time. See, it is not a program, so we are not supposed to write down the exact how much amount of time it is going to take. It is an algorithm. That's why what is our assumption? Each simple statement will take 1 unit of time. So here in this case, here you see there are three statements. This is my first statement, So this is my first statement, this is my second statement, and this is my third statement. So each statement will take 1 unit of time, 1 unit of time, and 1 unit of time. So total time taken by this particular algorithm is 3. But let us say there are such 1000 statements are there, or there are 5000 such statements are there. Still, we have to write down the complexity as order of 1. It is a constant. Now let us try to understand how the space complexity is found. Here in this algorithm, now there are various variables are there. Variable A is there, B is there, temp is there. So each variable you have to list here, right? So now one variable A is occupying 1 unit of space. Same way for B, it is occupying 1 unit of space. Same way for temporary variable, it is occupying 1 unit of space. So total space complexity of this, it is going to be equal to 3. Right? Let us see one more example where this example is adding n numbers of an array. Now here you see this particular program is algorithm is having one statement s equal to 0. It is always going to 1 unit of time. And here there is a for loop. Now it runs n time, but it is also going to check that condition when it becomes false. That's why this particular statement is going to be executed n plus 1 time. And here again the statement written inside this for loop will always run n number of time, and at the end this return s statement will get executed 1 time, right? So the total time taken by this particular algorithm is 1 plus n plus 1 plus n plus 1. That leads to f of n, it is equal to 2n plus 3. Now here you see all these are the constant value, 2, 3 we can ignore, right? So that's why the time complexity of f of n is equal to order of n. Let us also try to find out the space complexity for the same algorithm. So there is an array A and 3 variables are there, n, s and I. Now as A is an array and it may contain n number of elements, that's why the space will be taken by this is n in general, and the remaining 3 variables will take unit amount of space. That's why the space complexity equation is equal to n plus 3, or in general you can say order of n. Now you see in some case if you have used so many other variables, like some more variables that are there, and if you are having some equations like n plus 4 or n plus 5, still you can write down the space complexity as order of n. Let us take one more example. This example is matrix addition example, where we are adding two matrices A and B. So now here you see there are two for loops. A first for loop will run n plus 1 time. Inside that there is one more for loop will run n into n plus 1 time, right? And inside that there is one statement Cij, it is equal to Aij plus Bij, right? And this particular statement is inside these two for loops and it runs n into n unit of time. So the total time complexity will be f of n, it is equal to, right, you have to add all these numbers, right? So n plus 1 plus n into n plus 1 plus n into n. If you simplify this particular mathematical equation, right, you have to simplify the addition of these three, right? So it's very simple mathematics. You have to just add them and you will get f of n, it is equal to 2n square plus 2n plus 1. Now here the higher order term is order of n square. That's why the time complexity of this algorithm is going to be order of n square. Same way, let us try to find out the space complexity. So here there are three matrices. A is there, B is there, C is to store the addition of A and B. So now as they are two-dimensional array, that's why each will occupy order of n square space. And n, I, j are the three simple variables. So they will occupy 1, 1 and 1 space here. Right? So if we add them, the space complexity is 3n square plus 3, and in general the space complexity will be order of n square. Let us move to the next example. It is for matrix multiplication. So here, instead of multiplying two matrices, we are trying to multiply two matrices, right? So this is an homework example that I am giving you. You have to try to find out the time complexity for the same, and you also have to find out the space complexity. So this is an homework exercise so that you can try out yourself